Okay, so welcome to today's video. I want to do just a quick, again, review of graphing of radicals, just to make sure that you do have a grasp of that. So graphing of radicals, okay? Now, in particular, what we're going to say, let me just back up. Let me call that something else. It's graphing of square roots, not radicals. So square roots, okay? And we just solved equations with square roots, possibly, or according to what order we're doing these in, this might be coming before that. But we are just going to go ahead and get started with this. And an example, of course, would be the very simplest, f of x equals the square root of x. And so we are going to just take a quick look at what it looks like to do a square root. Now, I'm going to do this one just by a t-table, just to show you how it works. And when I go to put numbers in, guys, especially for square roots, I don't want to deal with decimal values. And so I am going to choose perfect squares that I know are going to work, because I want to take the square root of 0 would be 0. 1, square root of 1 would be 1. 2 I don't want to do because that's a decimal. 3 I don't want to do, it's a decimal. But 4 would be 2, 5, 6, 7, 8, 9 would be my next one I would want to do on there. And when we are doing the square root of these now, we are just doing, the square root of 0, the square root of 1. And so we're talking about just finding what we're calling our principal root. So anytime I ask you just for the square root of 9, that is asking you for 3, the principal root, where if I have the square root of a negative 9, that's a negative 3. Okay, so be sure you know the difference there. So when I go to graph this, I am going to have 0, 0. I'm going to have 1, 1. I'm going to have 4, 2. I'm going to have 9, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. There we go. And so this is the square root curve. That's what it looks like on there. So one of the things about it, again, is you will notice that it does look like a parabola laying on its side. It's just half of a parabola. So let's go ahead and get another one here real quick. So I'm going to do purple, and we're going to do f of x equals, we'll do something like the square root of x and then plus 1. Okay, so again, I'm going to do a quick t-table. The only thing I'm changing, of course, would be my answer. So if I put a 0 in, square root of 0 is 0, plus 1 is 1. Square root of 1 is 1, plus 1 is 2. Square root of 4 is 2, plus 1 is 3. Square root of 9 is 3, plus 1 is 10. Okay? And so now I'm going to come over here. Actually, I'm going to leave it purple, so I should have done that one in blue. Let me go back here. Okay, I'm going to just real quick go over this one in blue so that you see that this is technically my parent function. Okay, and then back to this one in purple. So I've got 0, 1. I've got 1, 2. I've got 4, 3. And I have, what did I just do? 9. You guys didn't stop me there. Screwed up. Square root of 9 is 3, plus 1 is 4. I'm not sure if that's what I said or not, but that's not what I definitely put. So 9, 4. Okay. And so again, here is my curve. So hopefully what you notice is by adding 1, again, I just moved it up. So if I had f of x equals the square root of x minus 1, hopefully you would say, well, that is now going to take and move everything down 1. Okay, which is the case. That is exactly what happens. So your square root curve moves just like your parabola. So what we could say then is that my vertex form of a quadratic, or of a square root would look like x minus h plus k. And again, your hk is this starting point here. Now, what we do want to look at, well, let me just do another problem here real quick, and then we'll go look at it. So if I have, get me another graph. Okay, so if I do have y equals the square root of x plus 1 minus 2. Okay, so that would put my vertex point at a -1, -2. So -1, -2. Okay, and I could find my x and my y intercept. Y intercept is definitely the easiest to find. I could put in x being 0, find my y, that would be what, a -1. Okay, I'm just substituting in. So I'm going to get 0, -1. And again, I could do my x-intercept on there. That is going to and then square both sides. Okay, so 4 equals x plus 1, x equals 3. So I am at 3, 0. Okay, 1, 2, 3, 0. Okay, and there is my curve again. Okay, so again, comparing it, that doesn't look very curvy, but you get the gist. Okay, now, very simple. We can follow all the same rules that we've done. Vertex, how to find the x-intercept, how to find the y-intercept. Again, the only thing is different is I am solving a radical problem, square root problem, not an x squared problem. So, next question, though, is what does the a do to it? Okay, what does the a do to it? So let's go back and just look at what an a would do to the problem. So I'm going to, again, go back to a blank graph here. Okay, and we're going to look at y equals 2 times the square root of x. Now, I'm going to go back real quick, and I'm going to put in 1, 0, 0, 1, 1. What did we have? 4, 1, 2, 3, 4, 2. So this is my original that we graphed earlier. So there's my parent function. Okay, there's the parent. And let's just see what happens when I do times 2. So I'm doing again, I'm going to just do me a t-table. It is the easiest here. So if I have the square root of 0, it's 0. Times 2 is still 0. So I did not move it off of the origin. I have 1. Square root of 1 is 1. Times 2 is 2. So I'm at 1, 2. 4. Square root of 4 is 2. 2 times 2 is 4. I'm at 4, 4. 1, 2, 3, 4. Okay. And the square root of 9 would be 3. 3 times 2 is 6, so I am at 9, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. Okay, so if you look at it, okay, a little bit different in the fact that when we had an x squared, okay, when we had just our general x squared, and I'm just going to just do a quick graph in here. Let's say this was our parent. If it had a 2x squared, remember it made it steeper because it went up twice as fast. Okay? It's going up twice as fast. So if you look at this, technically it is doing just the reverse or the inverse of what our x squared get with. So where our x squared went steeper, you would assume that this would come in maybe down in here. But in fact, it's going up twice as much. It's actually making it wider, if you want to think of it that way. Okay? So it is going up higher, twice as high. But if you think of it in terms of width of like your sideways parabola, it's getting wider. okay? Therefore, if you had a 1/2, then it would come inside here. So if I had y equals 1/2 square root of x, it would actually come inside here and be half of what I had to start off with. It's going to come in here, okay? So just so that you are aware of what the a value does. Now, if the a is negative, 100%, it is going to, y equals a -2 square root of x is going to just flip that entire, let me color code this again. Let's do this, y equals a -2 square root of x. There, color coded, okay? So what it does do, again, is it is going to flip it there, 1, 2, 3, 4, here, so forth. It does flip it upside down, okay? So that piece does not change, okay? So do be sure you are aware of what the graph of a square root curve does look like, okay? So good luck on that.